All right, it says I'm live. I'm gonna set up a few things real quick and then I'll get started. Okay, that seems to be working. All right. All right, so we are good to go. Here is the Highlander version 4. This is the current version as it is right now, except if you saw my post from Seattle, the back half of the robot is missing because it was too heavy. I used too thick of UHMW, so now I'm going to make something smaller and then make some other tweaks and changes as well. So the first thing we're going to do is make a new project, new design, and let's go ahead and save it. Call it the Highlander 5. We're on version 5 of this robot. And to keep everything organized, I'm going to give it its own folder. Save that. And here we are, our blank canvas. So to keep it organized, I'm going to move this inside of that folder when it finishes loading. I don't know if I can do that from here. Move to Highlander 5. Okay, so now it's actually where I want it. The first thing I'm going to do, the way I design my robots, is I'm going to make the base plate first and then kind of parametrically design everything around it. So I'm going to create a new component, and this will be the base plate. And then with that selected and the origin turned on, we will make a new sketch. And we'll press S on the pressing S brings up the menu here, and we're going to do a center rectangle right on the origin here. And then we'll give our square some dimensions. So I think it was something like 6 inches by 7 or something like that. That seems kind of big. Whenever you're making a sketch, you want to make sure that you always have all your lines black. If something isn't black, it's blue, it means it's undefined and it's not held down, as it were. So I'm going to open up the old version of Highlander here and see how big the base plate is, because it's not changing for this new version. So I will right click it and isolate it. So that way I can see just the base plate. Just sound check real quick. So there's 4 people watching. I assume one of those people is me. So one of the other 3 can let me know how the sound is. That'd be wonderful. So yeah, here's the base plate. I'm going to hit the I key to inspect. And we're at 6.645 inches with the base plate. And that's a really weird value. I think that's because I ended up doing half of a 1/4 inch or half of an 1/8 inch somewhere. And that made everything get weird. So I'll keep it at 6.5 for the next version. And then for width, it's 6. Okay. So 6 and then 6.5 for the length. And since we're doing this all parametrically, if I need to adjust this later, I can come back to the sketch and tweak it. So that's looking pretty good. That's a nice base plate. So we're going to grab this, hit the E key to extrude it, and this is going to be 1/16 of an inch. So I'll type 1/16, new body, and hit OK. And here is my base plate. Now, normally Fusion's default material is steel, I think. For me, that gets a little confusing because when everything's made out of metal, it's really obvious, or it's not obvious to tell what materials have the default material or something is actually steel, because that's very common to have a metal-y looking robot. So I changed mine to gold just so that it's extremely obvious that I'm using the default material. So this is going to be carbon fiber. So I'm going to right click this and hit physical material. And we're going to go down to, might be in plastic. Where is the carbon fiber? Yes. No, it's in here. Used it before. Not appearance, physical material. We don't want to just do the physical material or the appearance. We want the physical material as well, so that we can do weight calculations. My robots always turn out fat. Oh, thanks for the update, Nick. Also welcome. If I were carbon fiber, where would I be? What did I do for this? Carbon fiber, it's right there. I wonder if this was something custom that I made. Try and misc? No, just papers in there. What a thrilling live stream. Everyone at the edge of their seats as I try to find a material. Not going to be in metal, that would make sense. Okay, we're going to do it this way. We're going to duplicate this and then edit it. Carbon fiber. And to see what I did for this. Steal that. Made the window go away. and paste that in here. And then I know there's a carbon fiber appearance. And there we go. So kind of a roundabout way of doing that. But this should have carbon fiber. Whatever, mess with that later. Okay, so this is a nice base plate. Does base plate stuff. So the next thing I'm going to do is add the holes for the wheels. If we take a look back here, if I unisolate, you can see the guts if I take out the top plates and the wedges. So the way I do drive lightweight, because the pneumatics are fat, is to just zip tie the motors in, and I've had no problems with that so far. So let's see. Looks like I did the wheels, and the motors just hang on the edge there. So we'll do something similar. So with the base plate selected, and the reason we have the base plate is selected is so that when we select the base plate in the future and it gives us all the history down here in the corner, it'll only show the actions performed on that specific component instead of, you know, picking the root object and then looking at every action done ever, and that's a million items that we don't want to look at. So we're going to make a new sketch on top of the base plate here. And we're going to need some squares for the holes. Do 2-point rectangles for these. And don't have to be precise at this step. We just got to rough it. And then we'll add some constraints to make everything magically work together. So we know that these are all going to be equal to each other. So I'm going to add some equal constraints. Can click on stuff without clicking on everything else. Equal. All right, and then if we define one of these, I think it's something like 0.75 inches, they should all be that. Then for length, we'll say 1.5, and if we have to mess with this later, we can do so. But I'm going to make all of these equal as well. That way, if we change the wheel size or something like that, we only have to edit one number and everything will magically redefine itself. So we also know that these two lines are going to be collinear, because my wheels are going to be in the same spot up and down, obviously. So you can see if we drag one of these, the other one stays with it. And we'll do the same with these two. There we go. Now, if you look back at the old version, you can see that the wall pretty much takes all the room. It sets the distance between the hole and the edge of the robot is the width of the wall of the frame. So we're going to create a user parameter. And I'm going to add one of these, and I'm going to call it wall thickness. Spell it this way because that's funny. And this is going to be 1/4 inch. And for comment, just in case I forget, thickness of wall or UHMW chassis, something like that. Great. So with that parameter, we can access this variable wherever we want in the future. So I can say, for example, the distance between the edge of the base plate and the hole will be wall thickness. And now it's 1/4 inch. If later I decide that's too heavy or too light, I could go back to the user parameters. And then we could change this to like, oh, let's go 0.5 because pneumatics aren't heavy anymore. I found some amazing replacement valve, and then I can use massive armor. And you can see doing that automatically changed this distance. So let's put that back to the way it should be at 0.25. That's looking just dandy. And we want to do the same on this side, distance. Now, instead of typing it again, I'm just going to click this other dimension, and now they'll be the same because I want them to match. So you can see some of our lines are turning black and some of them are blue still. So that means we're getting closer to fully defining the sketch. So let's make these two lines collinear so that they're parallel to each other, and do the same with these over here. And I broke something. You and you. Collinear. There we go. Maybe I hit parallel instead of collinear. All right, and you can see on this side it is also only a 1/4 inch from the wall. Now let's do the vertical dimension. This, I believe, is the same. Yeah, it's the same for the back, but it is not the same for the front. So let's make this distance all thickness. And there, I only have to do it once because these are collinear. And for here to here, I think it's just a variable that we change. So I'm just going to say 0.5 for now, and if it needs to move, we'll do so. Oh, let's just look at what the old version was. We'll hit I, check from here to here, and it is 0.5, so we'll keep that the way it is at 0.5. So now you can see all the lines are black, and that means we're ready to extrude. But I also, in this step, want to add the motor holes for the zip ties. So I'm going to put those in there as well. I'm going to do that by making a line, making sure the center point is here, go all the way over here. I'm going to hit X to make it a construction line, and then do the same for the bottom one as well. There we go. And we're going to add some circles to center point circle. So again, I'm just going to throw these around wherever. We're going to add all the constraints later, so it doesn't matter how big they are or where they are placed physically. There we go. So we're going to make all these. There's some kind of shortcut to select everything that isn't, or like siblings might be the term. In Blender, there's a thing you can do where you select similar objects, and that would make life so much easier. But I was able to set them all to equal in one step, so that's nice. I don't recall the diameter of these. We'll take a look at the previous version, and it is some weird number that I assume is millimeters. So let me grab this diameter, go to the internet, see what that is in millimeters. It's 3.33. What a weird number. Oh, that's an M3. That's not a weird number at all. That's right, because holes in metric include 0.3 repeating in their value. And M5, I think, goes 5.55. M6 is 6.666, etc. So yeah, it's an M3 hole. So if we define one of these to be a 3 millimeter-ish diameter, they all automatically shrink, which is great. Let's add some more lines. I'm going to add a line from this circle to this circle, another line from this circle to this circle, and another line from this circle to this circle. Also, if you guys watching notice me doing something really stupidly and know a better way of doing it, that would be awesome. I'm sure I'm doing something wrong. So now I'll add another set of lines from this one to this one. Set of lines from this one to this one. Oh, that carbon fiber texture really makes it hard to see everything. These will all be construction lines as well. So now we need to start making everything coincident with each other. However you say coincident, one of those. This circle is bigger than everything else. Make sure those are equal. There we go. So this is going to be coincident of that. This is going to be coincident of this. This will be coincident of this. And this will be coincident of this one. And you can see it's all starting to snap together into a grid. I'm just going to hide the body here. You are coincident to this line. You are coincident to this line. This circle needs to equal all the other circles. This is coincident to this. These lines are all parallel. It's not going to let me do that because one's already parallel. Then you're parallel to this line. You're parallel to this line. Define this as a vertical line. You're parallel to this line. It's all starting to come together. We need another line here. This is a coincident of this line. You are coincident. Back down. All right, almost there. Okay, so looks like we're just about there. If we take a look here, you can see the distance from the first hole to the line here is 0.210 inches. That's probably something in millimeters again. So let's check that. .33, that's weird. Not sure where I came up with that number, but we'll just use it since it works. So the distance between this line and the hole of the wheel is that amount, and same thing for this side. Those equal to the same. All right, and then the distance between the first hole to the second hole is some weird magic number. So we're going to say this distance is that magic number, and this distance is also that magic number. There we go. Now we need the distance between the pair of holes vertically. I want that point, I want the circle. There you go, and that's a little bit over 0.5 inches. So from this line to this line, that amount, and then from this line to this line, that amount. Now we can catch these circles that weren't added. Same with you. Yes, there's a million icons on my desktop that need to be cleaned up. Kyle, you should use the sketch palette, because that's how you make everything parametric and magically work together to make awesome things that require less work. Make the computer do the work for you, as it were. Okay, so this is going to get a little sloppy now because I'm going to add a line between these 2 points, and it kind of covers the big line we have going here. Then I'm going to add another point and make sure it's in the center of this line. And then we take this point and the center line here, and that aligns everything vertically like that. So you can see everything just turned black because we got it locked in with all of its dimensions. It knows what diameter and what position it needs to be. So everything's locked in. Are you using strong stuff that is not too heavy from Home Depot? That's right, Warwick. That's how you mount weapons correctly. And you don't want things too heavy, otherwise it makes your robot illegal, and you want stuff that isn't too weak because it won't hold itself together. Very good observation. All right, so that one's all set. Now we'll do the one down here. Add another line and another point. And make that a coincident as well. So there we go. Now this is all purely defined parametrically. So I can select these big holes for the wheels, and then I can select each of the holes for the zip ties. Select. It's what I need is a select identical or some kind of command like that. To answer your question, Warwick, it will hold several pneumatics. If we're lucky, maybe more than last time, but we'll see. All right, so with everything selected, I'm going to hit the E key, or let's show the body so we see what happens here. And we're going to drag it down to make a cut. But instead of like that, we're going to change this to to object. And if we select the bottom of the base plate, it will cut exactly that amount. So later, if I decide, oh, I need a thicker base plate or I need a thinner base plate, it will automatically adjust itself because we said cut to the end of the base plate, not some random arbitrary amount. So we'll hit cut, and here we go. Our base plate is starting to look like a base plate. Now, to show you the magic of parametric modeling, let's go to that original sketch and say, oh, I need this to be 9 inches long. If we hit that and then remake the sketch, look at this. It has automatically shifted the holes to where they need to be. Everything here is still 0.5 inches from the edge, and everything here is still 1/4 inch, and it added all that extra space, all without us having to go through and remake everything. And that's what makes this sort of thing really cool. So I'll put this back to 6.5 so we can continue. All right, so let's add the motors. That's a fun thing to do. So to keep everything organized, I like to have my base plate as its own component because that's something I need to get to often to make changes. Then what we're going to do is create a new component, and we're going to call this drive system. And this is going to have all of the drive system components in it. So let's take a look through here and find that N20. There we go, motor M apparently. So we're going to drag that in. And there it is. Let's move it out of the way. We're going to need 4 of these. Motor. And you can see that they're, when you import files from other sections of your project, it implements them into the active component, which is my drive system. So that keeps everything nice and tidy, because if I don't want to see a million components on the sidebar, I can just close this and open it to my heart's content. All right, so here we have 4 glorious N20s, and let's add them to the base plate. So I'm going to hit the J key for joint, and I'm going to select the edge, the front edge of each one of these, and it will go towards the edge of one of these. And as you can see, it lines up right in the middle where the zip tie things are. It looks like it's off by a little bit. I'll have to double check those numbers. Then we'll check everything here. We want rigid, and that is great. So there we go. We have one attached here. If we move this around, it also keeps the motor attached because it's a joint, and that's what joints do. So let's do that with the rest of these. That over here, over there, flip that one. Okay, sometimes it gets a little picky. but just make sure it looks right. Another one. Here. And of course, if I were to go back into that original base plate sketch and then tweak the length of it to make it all, you know, an inch longer or an inch shorter, it would automatically move these motors to where they need to be because of the parametricness. You want to die during my video? Take a shot every time you hear me say parametric. And there we go. Let's demonstrate that because that's fun. So let's select the base plate. Now, if you noticed, if I select this, I have every single action I've ever done. If I select just the base plate, it gives me only the base plate actions. That makes finding your edits so much easier. Let's change this to 10 and hit stop sketch. And if you look at that, the motors have all automatically found the places they need to be after making that change. And that's the fun stuff. All right, so fix this back to 6.5. Bada bing, bada boom. All right, so I think these might be the wrong motors. And that's why they aren't looking correctly. Oh, that seems to be right though. Distance from here is 0.21. Distance to here is not 0.21. Not selecting the middle. That makes it weird. Normally it tells you the distance to the middle of the thing. Let's just check the sketch. Other sketch. Yeah, there's that 0.21. Strange. All right, well, let's add some wheels. So in the drive system, these are just going to be simple circles. Speak a little louder, but what do you mean, Warwick? Are you messing with me? You messing with me on my first live stream? Speak a little louder but softer. New component, call it wheel. I want to say I'm using 1 1/4 diameter wheels. Let's see. Yeah, 1.25. So with the drive or the wheel active, and to kind of get everything out of the way, I'm going to isolate it. We're going to make a new sketch and then add a circle. And notice I always want it on the origin because if you do it here, you're going to get a blue line, which isn't locked down. So let's make these coincidence and define this to be 1.25. So with this selected, we can extrude it, and I'm using 0.5-inch thick wheels and hit OK. And then we'll make these, I'm not sure what I was using for foam. I do not apply an actual physical material. I just use finger techs. On their website, they say how much their wheels weigh, and I just use that as a value. So I think I use some kind of, I think I actually used a rubber, even though it's not what it is. Yeah, soft rubber. Does that look like a wheel? Sure. It's all for cosmetics. Doesn't matter. Okay, so let's unisolate this wheel. Now to add the other ones, we can just copy and paste, Control-C, and then make sure we're doing normal paste instead of paste new, because we want every time we make a change to one of these wheels to make it change all the other wheels. So I don't know why that's not showing up, but I'm just going to Control-V it. Where are my wheels? Why are you doing this to me? Copy. Why is there no paste? Am I missing it? That's strange. Does it seem to be active? Okay. All right, I guess a different parrot needed to be active in order to Control-C, Control-V everything. There we go. 4 wheels. Now, since they were all copies of each other, if we go to one of these and edit the sketch, and then say, 2, and then stop the sketch, it makes all the other ones that same size. So put that back. Now let's add them to the motors. So I'm going to hit Joint, I'm going to hit J, and we're going to get it right in here. Now I want that middle piece. If I hold down Control, it will keep this face active, and then I can move the cursor over to it. And then that'll let it stick like that. So I'll give it a little bit of space just for making sure there's enough room. And we'll do the same with all these other ones. Email Productions, hello. And Kelly, not Kelly, Kevin, Team Widowmaker Combat Robots. Nice to have you guys join. I did 0.05 for that, just to keep everything consistent. I'm using magic numbers, but for this, it's fine. Also, that animation that the wheels do is pretty sweet. Little backflip. Bam. All right, so these are all the wheels. Now, I guess if we wanted this to be accurate, I should have used rotate joints instead of, what are they called? Rigid joints. If we edit this one and then say rotate, revolute, you can see the wheel turns. So then we can grab it and, oh, we can't grab it because we need to ground something. So what grounding does is cements that particular place in virtual space. So if we take the base plate and hit ground, this is now permanently attached and nothing else can wiggle. So now we can grab this wheel and spin it. Whee! There it goes. TML Productions, yes, this is for Cirque. Totally rebuilding Highlander. It's pretty much the same, but the way it's going to be fabricated is going to be different. So there we go. I'll put it back as rigid just so they're all the same, but technically they should all be revolutes. So there we go. I also have, I don't know if I have my hubs in here or not. I don't, but I have my small hubs, which are these guys. Whenever it feels like loading. So FingerTech snap hubs are pretty great, but what I don't like is how expensive they are. They're not heavy, but for a robot with pneumatics in it, they're heavy. And I don't like how much they compress the wheels on the 1/2-inch version because it kind of ruins the tires, I think. But these just slide in, press fit. Since this whole cut is here, it'll kind of expand around the shafts and clamp onto it. It worked great at Seattle. I didn't have any fail, so I will continue using them. And these are just 3D printed, and they weigh like 1 gram or 2 grams, something insanely tiny. So I will have 4 of those. Actually, we'll import some of these just to make sure everything's lined up right. Inserting design is blah, blah, blah. Okay. Just one limitation of Fusion is not letting you import from project to project, which is a huge pain, but I think you can still copy and paste. Maybe not. Okay, and that's probably why I didn't put them in the other design. So it's looking pretty good. Let's start making some walls. So let's add the back wall. So I'm going to create a new component, and this is going to be the back section. So let's start a folder called chassis. And here we'll have a new component, and we'll call it UHMW frame. And then inside of here, we'll have a new component, and we'll call it back wall. Sure. TML, hope I get a match. Yeah, I hope I get a match with you too, TML. That'd be fun. What robot do you have? You could type that in the chat. Warwick, am I afraid of Taco Cat? I'm afraid of ramming Taco Cat and then one of the blades randomly hitting me into a pit. That's kind of what I'm afraid of there. TML asks, are Warwick FingerTech wheels? Yes, those are the FingerTech foam wheels. 1.25 by 0.5 inch, and you can insert into current design. Can I? Let's go back and try that. Insert into current design. Yeah, I get that same error. So it has to be in the same project. Do you glue the tires? Yes, I do. I put a little dot of super glue. Friction is usually enough, but I'm considering just, laying on the glue because these are so easy to make that if the foam dies, I can just, like, the only reason I would replace this is to swap out the foam if the foam gets cut up. But since the 3D printed parts are super easy to make, I could just toss out one of the 3D printed hubs and put a fresh one onto a brand new hub or onto a brand new wheel without any problems. So we'll probably do that. All right, so we're making a wall. This is where things are going to get a little weird because my buddy Matthew Tompkins is the one who cut my UHMW with his Shapeoko CNC machine. Since I'm probably going to do that again, I'm going to have the UHMW kind of slot into each of the sections to make the fastening line up better, if that made any sense at all. So instead of making it the width of the back, it's actually going to stick out a little bit so that it has room for a slot to fit in. Warwick, thanks for stopping by. Definitely watch it later if you want to. All right, anyway, so we're going to make a new sketch on top of the base plate. We're going to have a wall like so. So it's going to, the back will still line up with the back, and this will still line up with this. The thickness we defined earlier, I guess that's already defined because I'm picking that same amount, but that is equal to the wall thickness. So I want to have, I think an 1/8 inch would be fine of overlap here. And then same on this side. Let's actually make a variable for this. We'll call it UHMW slot. So I can definitely see myself having to change this. My robot is this is a test Mark II. The picture on DB is from last year when it was just a wedge, but now it is a vertical saw. I am actually working on the titanium front wedge right now. Awesome. That'll be fun to fight. I don't think I've ever fought a saw before. I fought 2 vertical spinners at Motorama. I don't remember if they were vertical spinners or if they actually had saw blades. So that'll be cool. All right, so 1/8 inch for this variable. Throw it in there. We'll change this to UHMW slot. And this will also be UHMW slot. Oh, we have 7 people watching. That's like 6 more than I expected to be here. But I do like the chat. That's fun talking to you guys. All right, so let's select all this and hit E to extrude, and we'll have a wall. And I want to say 2 inches. A tall robot. We can go back here to check. 1.5, that's great. Oh, okay, it must be this part that's 2 inches. So redo this to be 1.5. There we go. So we want this to be UHMW, so we'll go to physical material, and I do know UHMW is in here, so we won't spend a ton of time digging around for that. There we go, UHMW, and they even have black. Isn't that awesome? So bam. That looks good. So you can kind of see once this one extrudes, I can have a little nubbin pick out into this, and that will help hold everything in place. So to demonstrate that, I will make a sidewall. So new sketch. Oh no, we don't want to make a new sketch. We need to make the component first. Always make the component first. So new component, we'll call it left wall. Now we'll make a new sketch. Get another rectangle. It'll be something like this, where this is collinear with that. And you can see everything is black, so that means we're ready to extrude. Extrude that. And it'll be the same distance to the top here. So again, we'll say to object, pick the top of this. I don't know what this does, but clicking it makes it work, so I click it. And here we go, new body. So that's looking good, except we don't have the slot in. So let's add that. Create a sketch here on the side, and then we'll add something like that. And we'll make this 0.5. Yeah, that's fine. And then in the center of this whole thing is where we want it to line up. How long am I planning to stream? I'm probably another hour and a half, which would be 5 o'clock Arizona time, whatever that is in rest of the world time. Add another point for the center of this, and then we want this point and this center line to be coincidence, and that makes everything centered. Now if I grab, why can't I grab you? Like this is in the way. Come around through here. There we go. And then extrude this. We'll have a little slot like that. So that's looking good. But then we need that there's, they're kind of meshed into each other. There's not actually a hole there. So I'm going to do combine, and it actually might be better to do this later. So I do all the combines at once. That's whatever. So we're going to do the back plate as the target, this as our tool, and we want to cut and then keep the tool after. So running that, now we actually have a hole in this piece that this can mesh into. So you can see, I mean, that's the whole reason I have this extra piece sticking out. So once I actually have these pieces in my hand and then put them together, I'll put in the screws, the holes for the screws, and then I can cut off with a saw this whole side piece to keep it flush, if that makes sense. TML, thanks for stopping by. Good luck with your holes. Yeah, and then that will make, that way when I put together everything, I won't have to hold it on the edge myself, and everything will line up nicely. So let's also make this UHMW to make it pretty. Want physical material. And we'll throw in UHMW. There we go. Good. Actually, I do know this edge isn't square like that. It's cut because that's where I have the wedge, like that. So let's go back to this sketch and change this so that we have a line going from here to here. And I have this at a 45-degree angle. There we go. And you can see that defines it. So now if we stop the sketch and then edit the extrude, we can deselect this chunk. Deselect. And hit OK. And what are you doing? Or is this the wrong extrusion? Oh, that's right. I made it on the bottom plane and then scaled it up. So that's not going to do anything. So let's bring back that sketch. Left wall sketches are visible. Here, and then we can just do another extrude. To object, cut. There we go. So now we have a slope. Now we can make the other wall. So I should be able to just copy and paste it because they're going to be identical. I'm not going to make any changes to one that will not be made to the other. Let's see here. Did you say this was being milled? If so, you won't get square cutouts. The corners will be rounded to the side. Yeah. He also uses an 1/8 inch end mill. So I mean, if you cut this, there will be, and later I can fill it, whichever version of saying that is correct. And there'll be a little 1/8 inch fillet here. So I did something similar with Doomforge, my Beetle, that UHMW chassis. It all has the 1/8 inch fillet holes, or yeah, in the fillet to account for that. That way no surprises happened when it was milled. Okay, so let's take our left wall, and normally I would just make a new sketch here, but since that's on the edge, we can still do it that way because that's fun. Pick this, and then this is offset by UHMW slot, or negative UHMW slot. And you can see that puts it right on the edge here where we want it. Now we can make a new component. Right wall. If I copy and paste, I have to change the name to left wall 1, left wall 2, and I guess I could say side wall 1, side wall 2, but I'd rather just have the name, so I'm going to do it this way. So we're going to make a new sketch on this plane that we just made. That was an offset plane up here, by the way. And we're going to hit P for project, and we're just going to change this to bodies and then select the entire left wall body. So we'll select all that, extrude it. This is going to be wall thickness, negative wall thickness. Go over there. There you go. And then again, we will make this black UHMW, because Highlander is an edgy robot. There you go. So now we'll do another. Okay, let's try this. Let's take the combine I did earlier and move it to the front, and then edit it, and then make the tool body that as well as this. Oh, there we go. And now hit OK, and now we have both holes. Pretty cool. So, starting to look like a robot. Now you can see we can move all these around, and that is not what we want. So we're going to do Shift J for an as-built joint. That means instead of selecting a point and another point to mesh together, you just select two things, and the way it is will be how it attaches. So we'll pick these two, and now you can see they're attached. So I can't move this anymore because it's attached to the base plate, which is grounded, as we did earlier. TKS says, where do you set those constraints? I've never used those. What constraints do you mean? So I don't remember what I was talking about earlier. If you could retype that, I'll answer your question. So let's do another Shift J for these two, and then another Shift J for these. So now everything is rigid and can't move, as life should be. I wasn't expecting to get this far so fast. I was expecting something to go horribly wrong and then spend hours trying to fix it. So since these are all going to be constants, like okay, if you hit the S key and then type change parameters, or parameters in my case, that'll bring you to this menu. Then you can hit the plus here to add a new variable and then give it a name and a value. And then doing that sort of thing. That way, if I need to change something, I can change everything at once by adjusting these values. So we'll hit OK. Get back to this. The way this is going to work is it's all going to be made from one piece of UHMW. It'll be a 1/4 inch tall and then like 2 feet by 2 feet to get everything I need. So while it's there, it would be handy for adding pilot holes to drill the UHMW pieces together. So let's go ahead and add those. So with my back wall selected, I'm going to add a new sketch, and we're going to make some points to where we want these holes to be. And it's doing stuff I don't want it to do. Now let's add a line anyway, because we're going to have to add a line. Go add another line. All right, I'm now seeing that I probably just could have made a square. Wonderful. So let's take a point here, and you can see it's the center of this wall area. That's going to be where it's the thickness of the wall. So we want these to be coincident, so they line up. Coincident. I really don't know which way it is. How are you supposed to pronounce that? That and that. There we go. So let's add a dimension to this and say, I guess 1 inch looks pretty good. Now the question is, why is this blue? Oh, it's because none of it's fixed. So let's add another line from the center of this to here. Construction line. These are all construction lines technically. And we'll take a point, put it on the center of this, and then make that center line up with this, and that'll center it. There you go. Now everything's black. So that's looking pretty good. We'll stop the sketch. So now if I hit H for hole, you can select all these, and we'll make some holes. Not that one. There you go. So I use, this will just be flat because it's going to drill all the way through. It'll be a 5/16 drill bit. That seems really big now that I look at it. Let's do 2 millimeter. Make it bigger later if I have to. But we don't want to go all this distance. We want to, again, do to object and just through this. There you go. You can see it's adding holes through here. Hit OK. And now we have some holes. So now when I get these, I'll have these holes here where I can start putting the screws in. And then since we have the slot here that holds this in place, it'll hold that there, and then I'll be able to thread in a wood screw into this to attach it. Then once it's attached, I can slice off this extra piece that I no longer need anymore. Sound like a plan? TML Productions, welcome back. I'm glad your holes were successfully drilled. We were just talking about drilling holes. So now we have that done. Let's add the inner frames. So if you look at Highlander, it's made out of 4 frames basically. So we're going to make one of these now, which is a very weird shape. let's just copy and paste it. I don't want to do all that weirdness again. Copy. chassis, this will be under UHMW frame, so then we'll paste. There we go. But what we do want to do to this is add another slot so that it can, so we know where it lines up on the back when we get these pieces. How much ground clearance is that? Enough, but I will measure it for you. Let's make a ground element. That's always fun. New component, we'll call it floor, just so we don't mix it up with grounding things. So this is going to be a construct plane, and we're going to make it a tangent plane, and we're going to make it tangent to one of the wheels here. And you can see that's crooked. We could mess with this, but I don't trust it. So instead, I'm going to use a reference plane, and I'll use the origin. I can hide all that. There. So selecting that makes it the same angle as the reference plane. So if we go back to looking at this from the side, it's like that, but we want it 180 degrees away from that. There. So there we go. So now we have a plane that's under the wheel here, and if we adjust the wheels, this plane will always stick to the bottom of the wheel like that. That way, if we adjust, yeah, that keeps everything parametric. So new sketch on this plane, and we're just going to make a big old rectangle. Make it 2 feet by 2 feet. 24, and then we'll extrude it down 1 inch. And let's get a nice nice chunk of wood. Yeah, look at that. I like that mahogany. I have to download it. Let's download it. I'm never going to use wood on a robot, so let's use it. It's kind of like a display stand for the robot. Yeah, look at that. So the whole point of doing this was so that we could measure the distance from the ground to that top thing of the robot. That. And there you go. It is 0.42815 inches of ground clearance. We close. And now we can, the floor kind of gets in the way, so we can turn it on and off. If we go to render, I bet that looks pretty nice. What a beautiful robot. Turn the base plate back on. Get that going. I'm not going to let it render all the way because it'll take... No, it's actually going pretty fast because we don't have a lot of materials in there. But look at that. It's what our robot would look like if we pushed it or displayed it on a nice mahogany display stand. All right, so stop that, turn the floor off, back to business. And that business is putting slots onto this. So the question will be how to line it up. What I would normally do is I'd create a offset plane from this and then move it in by a variable, and that distance would be another parameter. That's a really cool technique. Thank you. Thanks. Do you always work in inches? I work in both because like I can visualize inches being an American in my head more. If someone says 80 millimeters, I have to think about how long that is. If someone says 3 or 4 inches, that's much easier for me to visualize. So I usually make everything in inches, and then if something I'm working with is metric, I'll just use metric. So like the holes for the zip ties, those were M3s, just because that's what I picked. But for the most part, inches, yeah. It is a pain because then when I export, a STL file, my slicer thinks I'm working with metric units. So instead of something being 2 inches, it thinks it's 2 millimeters, and then everything's tiny. So I got to watch out for that. All right, back to this. How about we add a slot in the middle, and then we can use a sketch on the back to position it. That'll work. So I'll make it the same distance as these guys. So 0.5 inches, that's a nice number to work with. So with this selected as the active, this is what kills you in Fusion, is not selecting the element you want to be active with. Otherwise, you're trying to find that sketch you did, and it's in the parent, or oh, it's in the root, and I have to dig through everything. And that's no good. So we're going to make a nice rectangle. This was 0.5 inches, not 0.54, just 0.5. And it was 0.5 inches off the ground, like so. And then we'll extrude that out. This will be wall thickness, like that. That looks pretty good. Now we'll make a hole for it here instead of doing the combine thing. And then this way the sketch will be actually used to position where the inner wall frames are. So on the back wall, we'll make a new sketch and add another one of these rectangles. We're actually going to need 2. Okay, so this, and then one of the existing ones are going to be equal, of course. And I do not want that attached to whatever you assumed I wanted it attached to. Fusion, don't do that to me. Clear that. Whatever that was projected on, I don't want it. Same with you. Stop making assumptions, Fusion. All right, so this is going to be collinear. So clicking collinear makes this line line up with that line, and then make this line line up with this line. And we'll say the same for this. There we go. Now you can see some of our lines are still blue. That means we can move them, and that is not what we want. So I'm going to say the distance from the inside of this wall to the inside of this wall is something. So maybe 1.5. And then this will be equal to this. There you go. It all turns black. So let's reference the old design and see what this actually is. 2 inches, okay. So we'll make that 2, and then it automatically handles that one for us. Isn't that fun? So we will stop this sketch. And what I want to do is actually rename this, because I'm going to come back to it probably. So this sketch, I'm going to name it inner frame location. That way, if I ever need to change that again, I can go, oh yeah, inner frame, instead of trying to figure out what sketch 1 and sketch 2 are. So that looks pretty good. Now we'll select these guys and extrude them. Like that. Now we can make a joint from the middle of this to the outside of this, if it doesn't give me a center point. So how about the top edge to the top edge? And there we go. Flip it around. And it is in there now. Hit OK. All right, and there we have it. So now if, let's say I get a smaller air tank, I can go back to inner frame location, change it to 1.5. I don't want to change that one. I want to change this one to 1.5, so it adjusts the other one. And now it automatically moves it to its new spot without me having to edit anything else. So let's put it back to the 2 inches it needs to be. There we go. So now we need to make another one of these. So we'll take left in, which is what I called it apparently, and paste it, move it a little bit. So now it's going to be left 2 or something like that. Yeah, left 2. Let's put it in the UHMW frame folder. Or I guess assembly, whatever they call groups of components. So now let's take this, grab the top, and then connect it to this top. Flip it, and there we are. So now we have the inner pieces looking nice and shiny. I'm going to change this name to inner wall. So we have inner wall 1 and inner wall 2 instead of left wall 1, left wall 2, because that doesn't make any sense. So now we're going to need to make these holes again. So let's try grabbing those and moving them again. So this hole and the sketch I used to make it, let's bring that to this point in time. And of course, that made a lot of things break. I don't know why this sketch is, well, I guess because we imported it and it doesn't know what its origin is, I guess. Okay, so that is a problem. Maybe I should have just remade them instead of copying and pasting. I'll worry about that later. Back to this. So we need to add another set of holes. This time we're going to use our knowledge of knowing that this just needs to be a square to our advantage. And we'll add a point to the center of that and then line those two up like so. Lagging for a little bit there. All right, now make everything a construction line that needs to be a construction line. All right, and looks like everything's already where we need it to be. So now in the hole wizard, we will select all of these points because we also want holes here to drill into the back and then into the side piece. There we go. So now I'll have this piece when I get it delivered, just like this, and it has the holes ready for me to add screws into, and I won't have to do any extra lining up, so everything will kind of slide in. So that's looking good. Oh, I isolated, that's what I did. Unisolate, show everything else. So let's admire. It's been about, it feels like an hour, hour and a half, however long this has been going. Base plate. Why isn't my base plate there? There it is. Okay. So now this is all starting to come together. I need to adjust this to match this, but I think after the live stream I'll do it. Let's do the top plates. Those are fun. So that'll be part of the chassis. We'll make a new component, call them top plates. And new component, this will be left top plate. So we're going to make a new sketch on the top of this. And it'll be, I wonder if we can just project the geometry we need, which would be this section, this, and that. Hit OK. Let's see, I can't extrude what I want to extrude. So we'll have to add a line. There's already a line. There we go. And we'll add a line from here to here. This is where it's going to get kind of weird because this part isn't correct. So maybe I should just do that first. Let's get rid of all this. Get rid of that. Okay, so maybe if we edit the, because it brings the sketch with it, I believe, when you export or import a different file. So, oh yeah, this will work just fine. So we need this this line to line up here linearly, but it doesn't want to move. Can I do that? Let them move that. Let's use Fusion Noticing. Sorry if you already said this, but are the CAD for those hubs available online anywhere? They are not, but I can email them to you or something if you want. I'm gonna move you. If I get rid of all the constraints, I don't know if that'll work or not. Doesn't appear so. Okay, well, that's really annoying. So I just want to shift everything to where it needs to be. It's gonna be such a pain to fix that. Unless someone in the chat can save me. Me. Yeah, I'll just work on some other stuff that doesn't depend on it. Let's do some of the electronics. So I'm going to make a new component. This will be the electronics system. That up here. Let's leave it where it is. Let's make the battery. So whenever I can, I like to make my own batteries just using individual cells, because Highlander is a different kind of robot. It doesn't have a big brushless motor. So that means it doesn't need nearly as much power as other ants do. Currently, it runs a 100 milliamp hour battery, but I could probably get away with 80 or 50 if I could find that. But I just haven't been able to find a battery that tiny. So let's look at the old version. You can see this is what my battery looks like. Another advantage of building your own batteries is that you can arrange the cells however you want. So if I want something that's more narrow than wide, I can make my batteries like this. So let's open a new component, call it battery. And then inside of here, we'll make another component and we'll call it cell. And we'll isolate this and make a cell. A rectangle. And it's something like 10 millimeters by 5 millimeters. Those are probably definitely wrong. So it's 0.827 long, which is probably something nice in millimeters because it's a battery cell from Banggood I use usually. Then the width, well, I want to extrude it. I want this, and I'll extrude it towards me. So this is 0.62007. That, and then the extrusion distance is 0.3 something something something. Extrude that by this much. There we go, we have a cell. And with this active, we will copy and then paste, paste, paste. Like that. And then we can use some joints to put these all together. joints. If you guys would be interested, I could make a video about making your own batteries from individual cells, but I feel like for most people, just buying their own is what's needed more. So there's a battery, custom battery. Make everything else visible. Cell is what we isolated. Unisolate. There you go. Now we have a battery floating around. So here I'm going to make a joint on the bottom of the battery to just anywhere on this base plate, really. But instead of rigid, I'm going to do planar. And that just means it can go anywhere as long as these two faces are touching, basically. So we'll hit OK like that, and you can see I can move it. But I can't move it up. I can only move it away. So I can't move it up or down, except it's letting me move it up or down. Or no, it's not letting me move it up. It's moving horizontally. So yeah, so just take my word for it. It's stuck to that plane. Won't be able to move it around anywhere that isn't stuck to the bottom here. So that's handy when you're looking at it from a weird angle. You can move it like this and you know that it's still stuck to the bottom there. Battery video would be cool. I am running two 2S batteries in series to get 4S, and that's another way that works just fine. That way you can keep half on one part of the robot and half on the other part, just in case they're too big to fit together. That works just fine. So let's rotate this. Because it's going to be here somewhere against the wall. I don't know where exactly. And in fact, we could add another joint from this face to this face and also make it planar. And it's now, I'm requiring it to always be against this wall and always to be against the base plate here. And because I know it's going to be somewhere here, I just don't know where yet. So that lets you mess with it. All right. So that's looking good. Next up, we can add, it's really bugging me that I can't fix this thing yet. You know, let's just remake them. Let's pretend I'm doing this whole robot from scratch. Yeah, that was a lot of work, but hey, too bad. Not that one, the other inner one. I don't know why it does this. Instead of deleting it, it moves it to the next parent. That's super weird. I don't know why Fusion does that. If anyone knows why, that'd be a welcome piece of information. So let's remake that and call it left inner wall. Isolate it and make a new sketch. So what I think I'm going to do is just bounce back and forth to get all the dimensions of this thing. We'll isolate you too. All right. So not all of it will be based off this scope because we do want to parametrically size it based off the base plate. So let's actually unisolate and instead hide stuff that we don't need. So we don't need to see the drive system right now. We don't need to see the electronic system right now. We just need to see this stuff. So we will want to project this angle. It'll be something like that. And we'll want the top because we want those to match. And you can see that kind of builds the basic layout. Let's do the top of the base plate as well. I think I just have a line coming down like this. And I have something like that. And then this goes on for a while. And then another line down here. So these need to be at a 90-degree angle. We can use perpendicular tool for that. Same with this. Looks like it's there already though. And this is also lined up. So I'll make these two lines parallel and make this vertical. And it doesn't like that. Looks like it's attaching to something I don't want it to. Now make it vertical. Why are you up there? There you go. So let's get the distance of this guy. So from here to here is 0.25 inches. So we'll do that here as well. And the back thing is also 0.25 inches. And all these structures held up just fine during the Seattle event. So if it ain't broke, don't fix it. I'd like to see a video explaining ant-sized pneumatics if you haven't already made one. So I have not made one, and that's because pneumatics is such a touchy subject in this community. So, you know, my first thought was, of course, I'll make a video showing people how to do this, but then people tell me, no, you don't want to do that. Some kid's going to blow himself up or someone's going to get it hurt. It's all going to be your fault. You're going to give the reputation a bad, or you're going to give the community a bad reputation. And it seems a little excessive to me. I don't like withholding information. I don't think I would reveal, you know, all my secrets to the current version, but like the AVC version of Highlander was pretty simple and made with RC retract parts. And I think making a video on how to do basic pneumatics with that would be totally fine, because we're not doing any crazy mods that might get anyone hurt. So we'll see. I do have a plan for a simple transmitter mod that I'm going to be doing in the next few days once I get some parts in the mail. That'll definitely come up, but we'll see. All right, so is this, and then we have this little part that sticks up that the arm is attached to. So this whole thing, I believe, is 2 inches, 2.25 inches even, which is definitely above average height for an antweight. We're going to go up like that, go up, and then go down. This is a 90-degree angle, and make sure we're looking for everything to be black. How big is this piece? Distance from here to here is 1 inch. I don't need to know how to do it, but how much money does a pneumatic system cost for an ant? Not much. Let's see, the air tanks. Let me pull up the other version. No, I don't want to do that. The air tanks were, I want to say $9 each, and then I run 2 of them. So we'll just say 20. The most expensive thing is the valve, which is $30, but I run 2 of them in series so that I try to get double the airflow. So that's another 60. Then the ram itself, the Robert ones. Let's pull that up. So Robart, I keep wanting to say Robert, but it's Robart, is where you can get 99% of an antweight pneumatic system. So if we go to tanks, we have all of our tanks here. I use the X small ones because that's all I can get to fit. And it's Team Small Robots. Then we have all of our couplers here. So like you can use these for your angles and your T couplers for splitters. I actually found that the brass ones work pretty well, so I'm switching over to those. Then the cylinders are what you're actually going to want to use. Now, if you remember back in the day, Inertia Labs, the creators of Toro and T-Minus and most recently Bronco, they actually made a kit for antweight pneumatics. And what that kit used for a cylinder was actually a Robart cylinder. It's the 165 here. It's $30. You attach your tubing here, and then since it's a double action cylinder, you don't really need to use this top part. This would be if you wanted air to power the return. But in an ant, I would strongly recommend not doing that. Just use a spring or a rubber band. That way you can use all of your air for just flipping stuff. But that's its own video in itself. It's explaining how all these pieces would go together. So then that's $34 for the RAM. So what are we at? We're at like $120 or something like that. So it's definitely more expensive than a chunk of metal and a brushless motor, but it's pretty damn fun. Let me show you those valves real quick. So we go to Exakoi. This is a company, I want to say in Brazil. So I found these guys by digging on the Facebook group, just running a search for pneumatics, and just looking for anything at all to use as a valve. But I found these guys. Somebody posted, and they were even recommended by Xander, I think, in the Inertial Labs group or team. So it's this tiny little thing that you plug into your receiver, and once you flip a switch on your receiver, it'll open the valve, and then if you close the switch, it'll allow airflow from the cylinder to the exhaust. There's not really an exhaust port; it's just a hole, I think, in the bottom of the thing. So. And that's it. You just plug it into your receiver and you're good to go. All right, so back to this. If that does sound like a cool video, a simple, it won't be amazing. You're not going to be shooting anyone into the ceiling. But if you want to do a basic pneumatic setup, that's definitely a video I can make for you guys. So this is all starting to look correct. And there's a hole. There's a hole for the axle. Forgot about that. Or the shaft, I guess is the proper term. That's a weird number. Hopefully this is a less weird number. It's also a weird number. And that is a weird number. All right. We'll use some weird numbers. About a circle. Distance is weird number 1, and the distance between this and this, weird number 2. And that's not giving me the center. Neither is that. I hate it when it does that. Yeah. See if we can make it work. It does the center, not the outer edge of the circle. I don't think there's a way to get around that. Was it doing that with the other one? Is that why I'm getting weird numbers? Okay, that is why I'm getting weird numbers. Okay. Knowing me, I would use a 1/4 inch because I like 1/4 inch and 1/8 inch, and I don't use any other values ever. So if I do that, that does look right. That's probably what I did. Okay, that ain't too bad. If you compare that cost to a water jet cut titanium disc, plus brushless motors and ESC, really not bad. One of my goals is an antweight eruption from Robot Wars. Okay, that'd be pretty awesome. A video would be fantastic, but I understand if you would not want to. I think if I preface the video with tons of safety warnings just to get the community to calm down, it'd be fine. I'll add that to the list of videos to make right now. All right. Do both of your valves have its own dedicated tank since you have 2 tanks, or do you have the tanks connected? They share it. Either valve is connected to both tanks, if that makes sense. I did that so that I wouldn't have to have 2 infill valves, but it wouldn't be a bad idea to to each one have its own dedicated line. That way, if a connection or some tubing breaks on one, you only lose half of your air instead of all of your air. You just need to have the weight and space for some more couplers and T-fittings and stuff like that. So it's all trade-offs, just like everything else in this hobby. And then lastly, we'll need the diameter of this hole, which I would assume is an M4. Internet. Yeah, that's an M4. Millimeters. Much better. Okay, so now this is finally looking like a part. So we'll stop our sketch, select all this, and now extrude it to be wall thickness. And there we go. Now on the other one, you can see I did a chamfer here and a chamfer here. So I'll do my best to duplicate that. That'll also kind of depend on the other stuff, other components that we have. Let's make that a 1/4 inch, because that's a fun number. And this one as well. All this stuff in the way. If anyone knows in Fusion how to click through something, that would save me so much time. Hide that wall so I can click on that. Chamfer, and let's do another 1/4 inch. And if we need to change it, we can change it. And then I also fillet this guy to an unknown value, but I'm going to say 1/4 inch. That way, this is all a uniform amount. There we go. Now let's make this UHMW. Awesome. Oh, I need the slot hole to be in there. Let's see. And the thing is, you could hurt yourself just as much with a brushless spinner. Yeah. I feel like with a spinner, you get a little bit of warning. You know, it starts to spin up and then you can run away, but pneumatics will just blow up if you do it wrong. But I mean, as long as you don't take anything over its rated pressure, of course, that's not going to happen. But if you fill up a 100 PSI tank to 300 PSI, don't come crying to me if you have shrapnel in your face. To click through, click and hold should bring up a window with options. Select the one you want. Oh, okay. Another vote for a pneumatics video. Cool. Thanks, Chris. Let's try that. Unhide this. So I want to chamfer stuff. But there's, oh, look at that. And I can pick which face I want. That's pretty neat. So with this being active, and I want to select that edge, I can't because that's in the way, but if I click and hold, can I get this edge? I can. That is awesome. Thank you, Chris. Bada bing. Fusion rocks, never going back to SolidWorks. I tried SolidWorks for a very short amount of time because I had a license of it through my university. But then before I could mess with it more, they took it away and they said, hey, you're not a mechanical engineer, you're a software engineer, you can't have that. And then I wasn't able to mess with it anymore. So that was annoying, but I'm totally happy with Fusion and I recommend it to anyone who wants a free CAD program. So back to this, we need to add that slot. So let's project someone else's slot that already is in here. Like that. And stop the sketch. When we extrude, we'll also select that part. Okay, I guess I haven't made an actual face there. Let's add a square. There we go. I think that worked. If I hide this, ooh, that did something weird. Should be wall thickness. I don't know why that freaked out. And then select that as well. Okay. Everything good? Looks like it. My pleasure. Yes, Chris. And how did you learn Fusion? Okay, there is a guy on YouTube who is awesome. Okay, I think I just looked up Fusion 360 tutorials. This guy, Lars Christensen. Watch all of his videos. I will link. I'll put a link in the chat right now. There we go. So he has two different series I think you should watch. He has the Absolute Beginner series, and then I think he has something else like parametric, like just general parametric modeling. Tips and Tricks is probably good. Let's see, Absolute Beginner tutorials. Oh, how to model an assembly, I think. Yeah, he makes a drawer here. That one's super helpful, this series. Yeah, so I'd watch the Absolute Beginner series and then watch the Model and Assembly series. But then pretty much I think he has a joint series as well. Watch that. But pretty much anything this guy makes that's Fusion 360 related, check it out. I have a quick question. How can you get Fusion for free? Everyone says it's free, but when they do, they just mean the trial. Okay, so Fusion 360 is free for hobbyists, and to be a hobbyist, you have to make less than X amount of dollars per year with it, and I think it's something like $30,000 or $50,000, and I don't think anyone in combat robots makes that. I don't think anyone in combat robots makes money, just in general. But so as long as you go to the Fusion website, and I think there's, you can, if you download the free trial, it is a free trial technically, but if you register and make an account saying you're a hobbyist, it'll give you like I think a registration key, or it'll make your account a hobbyist account. Then you can log into Fusion with that account and you'll have the hobbyist credentials, and then you'll be good to go. And then you just have to, I think you have to renew it once a year or something like that to say you're still not making money. Oh, I'm already a subscriber. Yes, good. And I have 100K. Yeah, no one is making 100K with combat robotics, unfortunately. I mean, if I could do this for a job, I totally would. But it is unfortunately not the world we live in yet. All right, back to Highlander. So here we go. We have a nice little middle piece. So I'm going to put the back visible again. And we're going to do what we did before and make a joint like that, and then flip it. We do not want this planar. We want it to just to be rigid. And there it is. It's spot. So I guess this is technically the right inner, not the left. Here we go. Now, to make the other one and make use of the hole we already have here, I'm going to create a sketch, or I create the component first. I always forget to do that. This will be left inner. Add the sketch to this plane on the side. Now we're going to project the body of this guy, and then, hey, look, it's already done. Let's select all this. Extrude wall thickness. And there we go. And we have another one. Let's also give it the UHMW texture. And there we go. we have our inner frame all done. Now let's add the drive system back into visibility, make sure we can still see everything. Let's see. Really? Oh my gosh, this is fantastic. I have never made more than $0 from robots. Well, hey, congratulations! You qualify today as a hobbyist. Sign up now, Fusion 360. And LOL from Team Widowmaker. Let's see. So this is coming together nicely. One thing I noticed that I've been neglecting is that I want to add slots into the base plate as well. So if I had a tiny little slot poking out of this and a hole here, that would help line up all these pieces with the base plate. And if I have, because when I got these, they were curved, like they were bent a little bit. So I kind of had to bend them to where I thought they would be and then hold them in place and then drill through. And I feel like that really made it come out nowhere near as accurate as it could have been. So let's actually add a slot or two. But if I do that, it'll be fine. Yeah, let's go for it. So back to this guy, which was the first one. And since this one is a duplicate of this one, we want to edit the original. So right inner wall. So let's add a little slot here inside the sketch. There we go. So this amount, it's going to be a 1/16 of an inch. I guess as long as we keep the base plate in the sketch, we don't have to create a variable. So that's okay. But this, we'll say 0.5. And we'll position it, I guess in the middle of this thing. Or I could just line it up with this. Let's do it that way, because that's easier. So now everything's black. If we go back to our extrude here, we'll make sure we also select this, and that way we'll have a little notch, like so. And let's also add one to this. Maybe not here because there's not really room for it, and there's only just room for one screw to go up here, so that's totally fine. I'll be back. Need to find my LiPo charger. Yes, that is an important thing to have. See you in a bit. So that looks good. And then you can see from the duplicated one, it automatically added that little notch here as well. And that's what we're doing here. We're making the program do all the work for us. So now we need these holes to actually be in the base plate. So we're going to do combine. Our target will be the base plate because that's the thing we want holes in. Then the tool bodies are going to be these two guys. And we want to cut. So we want to cut holes using the shapes of these into our target. Now we could we do want to keep the tools. If you have this unchecked, it'll just remove your parts. And in this case, we don't want to do that. So make sure that's checked. Hit OK. And if we were to hide one of these, you can see that there is, in fact, a hole here. And if we were to go back and edit something, this hole will always be lined up to where that little notch section is because of how we've been doing things. So this is looking good. We're going to need pilot holes on the bottom here. We're also going to need a pilot hole for the screw that holds this part in place as well. But we do already have, or I thought we had, I wonder what happened to those. I thought we had holes in the back here. Looks like something broke. It's probably one of these warnings I have down here. Yep, this sketch seems to have a problem. Oh yeah, something definitely broke here. Yikes, what did you think you had to attach to up here? All right, I'm just gonna kill all that. Die. Okay, let's make a square. Something like that. And we need a point in the center there. Make this collinear. There we go. Now if we make this hole again, we'll just remake that. Okay, so now our holes are back. That's fixed. So now this will all jigsaw together, and then the screws will hold it in place. So I am digging this so far. I wonder if, you know, I added this extra lip just so this had something to slide into, but if it was just a C that it slid into, I wonder if that would be enough just to hold it in place. It's no biggie, I guess. All right. So let's throw some of the pneumatics in here just to see how we're doing spacing wise. So we'll unisolate this so we can see everything. Oh, here I have the hubs. I guess I only added the hubs to half the wheel, not even half the wheels, 3/4 of the wheels, and I just didn't do it to this one for whatever reason. Weird. All right, so let's view the air system. We have one of these guys. So I'll take a tank, copy it, we'll paste it after we create a home for it. Air system. Control V. No? Yes. Why do you like this fusion? Just let me do stuff. Paste new. There we go. All right, so that's going to be somewhere here. And then we'll have another one over here. It'll be something like this. Now, what I've never tried before is using a joint on a round object to a flat object. So if I hit joint, I can use these, not anything else. Cylindrical, I don't think that does what I needed to do. Yeah. All right, let's do it this way. We'll make it rigid. We'll pick that, and we'll pick this hole. That'll do something weird like that, but we can edit it. Edit it. Oh, it doesn't give me another axis to rotate on besides that. It's a pain. All right, let's do this to the side of the wall here. Yeah, like that, and then we can just mess with it till it's where we need it to be. So now I'm getting sloppy just eyeballing things. One, two. This is bad because if I change anything, it's all just gonna fall apart. Something like that. See, that seems fine. Looks like I'm clipping into my motors though. These are supposed to fit better. Strange. Let's get rid of that joint. I also noticed these are wobbling around. We don't want that. So we're gonna do Shift J for an as-built joint. Select the rail and then select the base plate. Same thing for the other one. Now those are fixed. Perfect. All right, so this working just fine. What's my distance here? Oh, it's more like 1 inch away. Okay, that explains that. So now let's do some cool parametric stuff. Let's select our base plate. We only have 4 things we have to look at. We can go to this one, which I should probably rename. Let's do that. So sketch 2, this is actually, let's call it motor position, because that's what this whole sketch defines. So now I can hover over it, see motor position, know right away that's what I need. Adjust that. So this isn't 0.5 inches away. It was an inch away or something like that. Yeah, that's an inch because it's selecting the edge, not the center. So that means this is hopefully not an inch because I'm wondering where that room is coming from. That's, looks like an inch to me. That's strange. Because it looks like these are also misaligned. Something is afoot here. Maybe it's just because it's not selecting the center, and that's what's messing with me so much. Does anyone know how I can get the center of the circle instead of an edge? That's really annoying. Using the measure tool. Body component. Yeah, I want that. Show snap points. There's a snap point. There we go. Bam. But not not that though. You. Okay, what if I do that, disable this, then select the edge? Okay, I beat you, Fusion. 0.2755 something something something. Let's go to where that was defined in our base plate. Not that sketch. I even labeled it just for this. That this? Yeah, it's this. Okay, 0.21, 0.27. Okay, so that should fix that. Do that, and actually this should just be this amount. So I only have to change one thing. Hit that. Okay, now the holes line up because the zip tie fits perfectly between this little section of the motor and then wraps around. So you can see there's a gear sticking up, but if you rotate these a certain way, you can get them to a certain orientation where the zip tie won't hit the gears, and then everything's just fine. All right, TML, okay, I'm back. How many flips can you get out of your bot? Good question. Also, welcome back. So since Highlander is an unregulated system, that means it has, whatever your air tank pressure is also what the rest of the system works off of. So if you have 100 PSI and you release a little bit of air, it's going to be less, of course, because you got rid of some of it. So with the volume of the cylinder, and if you divide the volume by the cylinder of the volume of your air tank, that'll tell you how many flips you get. But it's not the same every single time, so that math doesn't work out. So it's more like I do a flip, it's at 97 PSI, I do another flip, then it's at 95, then 93, and then it kind of loses. It's not a linear line, it's more of a parabolic curve. So it's more like I get X amount of flips until it hits 0, growing slowly weaker over time. So I could say a good estimation is like 3 PSI is what I lose. So 100 divided by 3 is something, and that's about how many flips I get. But by the time I get to that last flip, it's at 3 PSI and not even strong enough to lift a robot. That makes it a little tricky to predict how much you're working with. A regulated system is so much easier to predict. If any of that made sense, me just rambling. So we have that lined up, but there's still not enough room between these, because it should be just like this, where there's barely any room between the motors and the cylinder. So let's measure this distance using the snap points. So we have that hole and this hole is 3.86. If we do it here, between that and that, it is 3.73. So we have a different amount for some reason. Oh, I remember why. It's because that, if you remember, we made the base plate, we rounded how long the initial size was. And doing that is what is kicking me. So instead of 3.5, it was something like 3.7 something. So let's do 6.75 on the length here. And now everything will magically rebuild itself to be this new size. So you can see this is still an inch away. This motor is still 0.5 inches away, et cetera, et cetera. If we show this, there we go. We can see that now it fits. Looks like we went a little too far. So let me just grab that exact number from the original version. 3.5. Oh, I remember this was, yeah, this initial sketch was weird because I added a little 1/4 inch at the last second to, I was going to do this thing with the back panel that never worked out. So instead of using that, let's just use what the actual final value is. And that's 6.645. So in here, .645. I think I'm just going to do 6.7. I did have a little bit of trouble getting it to fit. So that'll give us a little more wiggle room. There you go. Just like that, because these zip ties do take up space. And I think that'll be just fine the way it is, like that. So just kind of eyeball these for now. Get them on the ground at least. Yeah, as long as it fits under there. I remember adjusting this to fit the tank snugly. Looks like it's fine. I saw a valve that supposedly could do around 145 PSI, but the website looked old. You can definitely share a link if you want. 145 PSI would be great, but the tanks I use only hold 100. So that's kind of the limit there. Or actually, I think they can do 110. But then just pure PSI isn't enough. What's really more important is the flow rate of the valve. Because if you have a ton of pressure, but it's barely oozing out of the valve, that's not going to send robots into the air. It just makes a very strong lifter. You could lift something really heavy, but it's not going to launch. But yeah, if you want to share that, it's totally fine. We can check it out. So let's see. What do we want to... Oh, I just noticed these aren't right. Oh, those aren't right at all. What happened here? So it looks like I made the notches much longer than they needed to be. So let's go, so we don't have to dig through the whole thing. We'll just select right inner. It looks like this sketch went wrong. Oh, okay, I see what we did. So there was a gap here. Or it looks like I only had to, wow, this is strange. 2.5, I don't know what all this on the edges. Okay, so this should all just be solid. So that just means in the extrude here, we have to make sure we select these, but there's not a complete wraparound here. So let's add that. I guess what's actually happening is that this whole thing needs to be shifted over. something is stopping it from moving. Maybe it's you. No. Kinda. That's. I'm just gonna delete stuff. Nothing will die. Okay, so you should be here. So that just leaves this. I don't even know what it's. What are you projecting? It's gonna kill this whole section. Okay. So can this move? Still can't move. Okay, well we know it's none of that. Delete you. So something is stopping this from sliding over. So I should just be able to click and drag that. Oh, it's because there's nothing there. That's the wall. Okay, so the U, that's a silly reason. And U need to be collinear. I have to project it first. Project U. Okay, so now U and U slide over. There we go. And there should be a line from here to here. So I guess I'm looking at the other components instead of doing what's actually there. I guess that's why I usually isolate things before. I isolate them before actually building the sketch so that I know what exists in the sketch and what's actually just a line on the other side of the design. So isolate 90-degree angle, and this is a 1/4 inch. Okay, but you can see things are not all black. It'd also be a 1/4 inch, and this, well, this just needs to be perpendicular to that. There we go. Okay, so now everything's black. Everything should now export correctly. Looks like doing this made new edges. Oh, the extrude just failed terribly. So when I extrude that, and it does have our slot. And we want the other slot that is here. So let's hide the back wall. It's not there. I think I deleted it when I was madly going back through this. Okay, so now if we extrude it like that as well, and does that make all of our problems go away? No. How about now? There we go. Okay. Ah, that was an adventure. But it did not like this chamfer after we did that. I think that's this chamfer is the one by the front, so this is the back chamfer. Okay, that's happy now. The joint is a warning for some reason. Missing original reference. So let's select that again, because I guess since we made a new extrude of it, that's what made it cut it out. Makes sense. I found it again. It's nearly more than twice the price of the Exakoi valves. I'll message it to you since YouTube doesn't allow links. Okay. Is there a way I can allow links, or is that just YouTube in general and not something I can change? Because I'd be totally fine letting people post links. It's not like I'm getting a million people commenting and spamming in here, so it's definitely not a big deal. Okay, so that's fixed now. But the left inner broke. So let's make sure it's selecting the right stuff. There you go. That is good. All right, and now these need to be fixed. So whatever happened here. I think the left wall was the original one when I made these. So during this extrude, okay, why is it only to there? Oh, I see. Okay, so this is what happens when you don't make everything black. This can wiggle, and it decided it wanted to be here instead of up here. So now we're going to lock it there by making that linear. There we go. So now is it all happy? Okay, everything looks good. Cool. If you replace the dot with an actual dot, like you do, like what I just typed, something.com, I can piece it together. Oh, okay, messaging works too. All right, let's take a look at the valve. Evo Jet Orbit Pro. Neat. So 21 grams. Let's see how much the Exakoi weighs, because I think it's something in that same ballpark. And let's put these side by side. All right, so competitor number one on the left weighs 21 grams, while this one only weighs 18. It's only 3 grams, so it's not too bad. If this is amazing, then that's definitely worth it. So, section, you 3mm Robert, 4mm tubing, so we'd be stuck on that probably. And then our flow rate is 12 liters per minute. If we could get that into SCFM, that's something I'm much more familiar with. So 12 liters per minute is 0.42 cubic feet per minute. Now I have a spreadsheet, not on this account, my other account. I'm comparing all these valves. So here we can see a good SCFM, like the inertial labs, is 2.14. So this seems to have a really slow flow rate if I'm converting this correctly. And 10 bar to PSI is 145, okay. Let's see. I don't think this one has a flow rating on it. And then dimensions, it's 33 by 15. And it's about the same size. It's cute. Yeah, but it looks like the same deal, just plug it directly to your receiver. So yeah, the only thing concerning me is that the flow rate is so low, 12 liters per minute. The Exakoi, oh yeah, I never actually found what the flow rates were for these. But yeah, I have a lot of things that I've been checking and comparing, but most of it is too heavy, as is everything with antweight pneumatics. Okay, so CFM is cubic feet per minute, and I think SCFM was just standard cubic feet per minute or something like that. I don't know if that's actually a different thing. CFM feet per, okay, acre feet, barrels per minute. Okay, we have acre feet, cubic feet. Okay, those are the only two we have on this particular website. Yeah, I would have to double check all these units. Is there a thing? Let's explore a difference between SCFM and CFM. Air densities change with pressure and temperature. Okay, so there, SCFM might have it at a specific temperature that's different than CFM. So that's more comparing I can do later. But since I can post links, we'll put that there if anyone else wants to mess with it. All right, cool. I have a picture of my database now. Okay, yeah, let's check out your robot. Here insert, can't wait. And this is a test mark II. Is this it? Neat. So my question for you is, how does it work upside down? That looks like a big brushless motor for an antweight. Very cool. So I fought a Saifu kit like this at Seattle Bod Battles and flipped it into the pit. So I fear no Saifu kit now. I'm more scared of big spinners. You know, I've been going to the same events as David Rush for like 2 years or something like that, and we have never fought each other before. So maybe we'll get a chance to do that at Cirque. Oh, and Crave. I can't wait to flip Crave. It's kind of like the whole reason I'm going is to flip Crave. All right, back to the CAD. This is looking pretty good for now. I think I will leave it to questions or anything you guys want to talk about. I think I'm done CADing for now, so anything you guys want to discuss or look at, we can do that for the next 15 minutes or so, and then I'm going to go eat dinner. Can pull up some of the fights while we're waiting for people. Oh, this is my Facebook page that you guys should all go totally like. It's Team Small Robots, facebook.com/Team Small Robots. Get that in there. Thanks for checking it out. No problem. I got to fight him with his own robot. Oh, that's right. Yeah, at the Arizona event, you got to fight Rush with Rush. And should be able to drive on its side. Cool. My plan, I think, is going to be the same plan I used for Seattle, and that's just flip everybody into the pit. So let's find one of those. There you go. think this one maybe. Can you guys hear this? Can you hear the video sound? So this is Lich King, I think, horizontal spinner. So you can see half of the, and I'm going to do an event report on this, but I'll give you guys a little sneak peek since you're watching the live stream. It's something was horribly miscalculated on my part, and the what's it called? Weight was just horribly off. So I had to cut the entire half of the robot off and just run with duct tape armor on the back and top and sides. But it still went like 4-2, I think, 5-2. He got 5th place. So you can see I just dumped him in the pit. So that was a lot of fun. I'm looking for Flex because I like that fight a lot. Is this Flex? Oh no, this is the Saifu kit. Woo. So pretty much this whole event was me scooping somebody up and then flipping them in the, well, in this case behind the pit. And that's how it would keep winning. And since Cirque also has a pit, I'm looking forward to pitting people there as well. What happened to Gimli during the Robo Games Rumble? Are you talking about 2018 or 17? Well, probably. Yeah, I don't think it did a Rumble. Is that a video somewhere? Or it'll be Robo Games. Can't wait, Rumble. Yeah, so the whole entire event, I was having receiver problems, and it wasn't just like bad little issues. It was like it was unbinding itself and resetting all the settings I made. So Gimli would, oh, this is an antweight. Gimli is a fairy weight. So I would turn it on and it would unbind itself, and then it would spin in a circle, turning on the weapon at full speed. And that's super dangerous. It would get rid of all the failsafe settings, and then I would have to rebind it to the receiver. So after each one of my fights where you see it stop randomly, all I had to do was rebind it, and then it would work fine for a few more minutes. But then eventually it would unbind itself again. And that just made it such a frustrating event. But I think that's all that really happens, is that the receiver decides, hey, it's time to unbind, and then it doesn't use that again. So I'm going to go back to using the receiver I used at Motorama, where Gimli got 3rd place, and just stick with that because that worked great. But I think, yeah, I thought I was stuck, but I'm not stuck. It's just the receiver being a terrible receiver. So that was on Banggood. FlySky Micro, because I use FlySky radio stuff. I've never had any problems with FlySky gear until I used this receiver. So this guy, it's an 8-channel, but it's super tiny. It was just such a headache. The guy who built Swarf recommended this one to me. It's the same size, but it's only 4 channels. And what I've done with testing so far, it's totally fine. So I think I'm going to switch to this permanently. And that will hopefully solve all my problems. All right. So hopefully that answers that question. It was just a really embarrassing mistake on my part. Oh yeah, Doom Porch. Thanks, Kevin. So I'm so bad keeping up with all the events that I've been in. At Robo Games last year, I haven't made an event report for it, but I did get to fight in a Rumble with my beetle weight. They took all the flamethrowers, no matter what weight class you're in, and then said, let's stick that in a big Rumble together. And that was super hilarious. There you go. All right, so I'll pause this here. So we have over here, we have Raging Scotsman, 220 pounds. We have Kevin's robot, Tastes Like Burning, 60 pounder. We have Chewy's Dumpster Fire, middleweight. And then we have Crash and Burn, the heavyweight. And then we have Doom Porridge. We have my Beetle fighting all of these other flamethrower robots. And it was amazing. My flamethrower was broken from fighting a drum spinner, but somewhere in here I take a direct hit to the face from Raging Scotsman. Because Doomforge knows no fear. Here it is. It's the big face full of fire. And then the announcers got my robot's name wrong. Instead of Doomforge, like a fire forge, they said porch. Like a, outside your house, you go sit on the porch. Doom porch. It's like, come on, guys, really? Good times, though. I had receiver issues with Roomba, but every hit I took hit my bind button. Oh, okay. But I wonder if that's what happened, because I do have a bind button on those things. Maybe hitting the... Did you use a similar receiver? And maybe just the vibrations caused the button to push? That's kind of weird if that's what happened. Would you say it is dangerous doing pneumatics even if you take all the precautions and don't go over the PSI? At an antweight, it is definitely much less dangerous, because the worst thing that can happen if you stay under all the regulations is a fitting comes loose. If that happens on an antweight, it'll just make a really loud and scary psst noise, and that's nothing. Or you could fire the weapon accidentally, and on an antweight, it might hurt if you have like your face right by the arm, I guess, because that's, I mean, my cylinder, at least, it's 45 pounds of force that comes at you in an instant, so that could hurt a little bit. It's not fatal, but I definitely recommend being careful about it. If you have a big robot, and you have, if you're working on Bronco and you have all your regulated things, but the arm fires accidentally, that's going to kill you. So you definitely want to be careful with that sort of thing. If you ever heard the saying, pretend there's no such thing as an unloaded gun, do that with pneumatics. There's no such thing as an unpressurized arm, and just when you're working on it and handling it, just pretend that arm could fire at any moment. That way you'll always be safe. All right. So I guess we're kind of running out of things to talk about. So I'll definitely try to make a pneumatics video in the future. Just a simple how to get started. Something simple. We'll have the radio transmitter mod I'm doing. So that's simple. It's just, if we look at an FSI6, I love this transmitter. It's only $50. It's like $40 in some places. And it does everything you need. I've had no problems with it, just with that specific receiver. Let's take a look at it. But you can see it has 2 switches here, 2 switches here. This switch is actually a 3 position, but there's no push buttons on the thing. So what I would like is a push button to replace one of these switches, so that when I fire the arm, or if I ignite the igniter in Doomforge, I can just let go of it and forget about it. Because if you watch some of my fights, you'll notice that my arm keeps flipping up and down, and that's not because I'm having electrical problems. It's because it's just me forgetting if up is the on position or if down is the on position for the arm. And I don't know, just it's all user error on my part. For some reason, it confuses me in the heat of a match. So if it was just a button, and if I push it, that makes the arm go up. If I let go, the arm comes down. That'd be so nice and convenient for me, at least. So I'm going to be on the underneath side of this, drilling a hole, putting in the button, and then wiring the button to the switch, so that pushing the button does the same thing as pushing the switch. So yeah, those are also future videos. I also want to do a build montage on Gimli. I have all the footage for it, but Gimli's gone through 2 revisions since then, because this was the Motorama version, and I've gone to Robo Games and Seattle since then. So lots of things that need to change, or would change and that would make that video totally irrelevant. So probably for the next version of Gimli, which would be, I guess, Motorama next year, that's what I'll make the build montage for. So there we have it. I used to flick the rudder stick for my 3-pound flipper. Oh, okay. I guess if one of my switches would spring return, that'd be nice. I guess I could slap the side stick one way. That'd be kind of weird though. I'd rather just use a button. Plus it's fun to mod stuff. I'm going to try a foot pedal for ignition. That'd be cool. I think, what was the name of that robot? It was Banana Smoothie or something like that. The guy used a foot pedal for his flipper. I think that was, it wasn't a spring-loaded flipper. It was just like a really beefy brushless motor flipper or something like that. It was pretty cool. And he would just stomp on the pedal and that would be the flipper. All right, so I think that will do it for this live stream. Any more things you want to bring up, please do so in the next like 10 seconds. Otherwise, I'm gonna close it. But it's been great having you guys. Any feedback would be appreciated. Things I could do better, things you'd like to see in future videos, leave a comment. So great.